Imagine a world where machines don't just follow instructions, but understand context, anticipate needs, and reason through problems like humans do. That's not science fiction. It's the frontier of artificial intelligence today, and at its heart lies a revolution in how we train models to think. For years, we've relied on a simple idea. Show the model lots of examples, and it learns patterns. That's how large language models like GPT or Llama became so powerful. But here's the catch. This approach has a blind spot. It's great at predicting the next word, but it struggles with true reasoning, especially when faced with novel or complex problems. Enter chain of thought prompting, a breakthrough that changes everything. Instead of just asking a model to give a final answer, we teach it to think out loud. We prompt it to break down a problem step by step. Let's think step by step. And suddenly the model doesn't just guess, it reasons. Take this example. If a train leaves station A at 60 mph and another leaves station B at 40 mph, and they're 500 miles apart, when will they meet? A standard prompt might get you a wrong answer, because the model just predicts the most likely output. But with chain of thought, you get this. First, the trains are moving toward each other, so their speeds add. 60 plus 40 equals 100 mph combined speed. The distance is 500 miles. Time equals distance, speed, so 500 divided by 100 equals 5 hours. They'll meet in 5 hours. That's not just a correct answer, it's a traceable logical path. And this isn't magic. It's a shift in how we guide the model's internal computation. But here's where it gets deeper. Chain of thought wasn't just a clever trick, it was a discovery. Researchers at Google found that if you generate these reasoning steps during training, instead of just asking for them at inference time, you get models that reason better by default. This led to self-consistency, a method where the model runs multiple chains of thought, then votes on the most consistent answer. It's like having a team of AI thinkers debate and converge on the best solution. But why does this work? Because the model isn't just memorizing patterns, it's learning to simulate reasoning as part of its internal architecture. Now push further. What if we could teach a model not just to reason, but to debug its own reasoning? Enter RAACT prompting, a fusion of reasoning and action. The model doesn't just think, it acts. It plans, checks, and revises. For example, if asked to solve a math problem, it might say, I need to find the area of a triangle. I'll use the formula, a half times base times height. Let me look up the base and height. Then it simulates accessing data, recalculates, and revises. This is the next leap. Models that don't just simulate thought, they interact with their environment just like a human would. And the most exciting development: programmated reasoning. Instead of relying solely on language, we let the model generate actual code, Python, JavaScript, even symbolic logic, to solve problems. It writes a script, runs it in a sandbox, and uses the output to refine its answer. Imagine asking, how many prime numbers are there between 1 and 1,000? The model doesn't just guess. It generates a loop, tests each number, counts the primes, and returns the result with proof. This isn't just accuracy, it's verifiability. The reasoning path is executable. You can audit it. You can trust it. But here's the real breakthrough: training models on reasoning data. Researchers have started creating massive datasets of multi-step problems: math, logic, coding, scientific reasoning, paired with correct chains of thought. Models trained on this data learn not just to mimic reasoning, but to perform it. And the results? A 20% to 50% improvement in complex reasoning tasks compared to standard models. Some models now outperform humans on certain math benchmarks. But this isn't just about better answers, it's about understanding. When a model explains its steps, we can see how it thinks. We can identify flaws. We can teach it better. And this is where we stand today. AI is no longer just a pattern matcher. It's becoming a reasoning engine. So what's next? We're seeing models that reason across domains, connecting physics to economics, biology to ethics. We're building systems that simulate scientific discovery, propose hypotheses, and test them. The future isn't about bigger models. It's about smarter reasoning. Because when machines can think, not just predict, we unlock a new era of collaboration, discovery, and innovation. This isn't the end of the journey. It's just the beginning.